We're going to go over quadratic formula again, but we're going over two special cases. Before we went over with two x-intercepts, we're going to go over one natural root, which means one x-intercept, and zero natural roots, which means there are no x-intercepts, but there's still a parabola. So, quickly, because you've practiced this a few times now, here's our a value, here's our b, here's our c. I'm going to show you how we can kind of speed up this process. Okay, we're going to plug these values in. My b value is positive 4, so when I apply the negative, it'll become negative 4. Plus or minus the square root of, well, 4 squared is going to be 16. And then you have negative 4 times a, so negative 4 times 2 is negative 8, times the other 2 is negative 16. So negative 16 divided by, and 2 times a, our a value was 2, so it will be 4. Then equals negative 4 plus or minus the root of 0 divided by 4. So you notice in like 2 steps, I'm already at the point where I split. Okay, you can't speed up this process. You don't have to write everything down, but it does help you make fewer mistakes if you do go through every step. Not as many in your head. Now, if you guys notice root 0, well, what is the root of 0? 0. Okay, so I split this, let's say, but we're going to get something interesting here. X will be equal to negative 4 plus 0 divided by 4. And x will be equal to negative 4 minus 0 divided by 4. Negative 4 plus 0 is negative 4 divided by 4 is negative 1. Same thing over here. Our x-intercepts are what? So in other words, we only have one. When our bracket reads a 0, we only have one x-intercept. Okay, well, what does that mean if we're sketching this? Very good. So if there's only one x-intercept at negative 1, and the parabola opens upwards because a is positive, the vertex is what's hitting the x-intercept.
So you
okay?
just go x squared?
That's it. The vertex is equaling the x-intercept. There's only one x-intercept.
But to expand the parabola, you just...
We don't need to expand this. This is all it's asking.
So if both of them are the same, that's where the vertex is?
We'll go through the last example, which is 8x squared plus 1x plus 5. Okay. Y equals 8x squared plus x plus 5. Okay, I'm not even going to write the quadratic formula. From memory, we're going to go through this. So x is equal to negative b. Well, our b value is 1, so that's going to be negative 1. Plus or minus the square root plus or minus our b squared, again, is 1, so we have 1 squared. Negative 4 times, I'm actually going to go right to the c, okay? It'll make it a little easier for me to multiply. Negative 4 times 5, negative 20, times 8, negative 160. Okay, and we know 1 squared is just going to be 1. All of that will be divided by 2 times 8, which gives us 16. Now, we're going to get x is equal to negative 1 plus or minus the square root of negative 159 divided by
You have to put that plus
16.
minus,
Yeah, we got to put that plus minus. Now, root of a negative term. Can I root a negative term? No, there is no root of a negative term, right? If I were to play, for example, say we're looking at root negative 9. Well, positive 3 times positive 3 gives us positive 9. Negative 3 by negative 3 gives us positive 9. That's supposed to be a multiplication sign. The only way I can get negative 9 is if I did negative 3 times positive 3. But those aren't the same terms. So there's no root of a negative term. So in other words, there are no x-intercepts. What does that mean in terms of a parabola? What about the vertex? If I have a vertex up here, which way is this parabola facing?
Down.
That means it's not crossing the x-intercept. Okay? And if I have a vertex down here, it's facing downwards. So it's not that it's not a parabola, it just never crosses the x-intercepts or the x-axis. That was it. There are no real roots. That would be our answer. No real roots for this.
Leave it.
Leave it.